Okay, matrix. Topic natin ngayon is yung matrix. So, definition ng matrix. A matrix is a rectangular array of numbers arranged in rows and columns. So, this is the row and ito yung column. The array of numbers below is an example of matrix. So, ito nakikita nyo to. Okay, example lang naman ito ng form. So, this is a 4 by 3 matrix. So, the number of rows and column that a matrix has is called its dimension or its order. By convention, rows are listed first, ito, and columns. So therefore, thus, we would say that the dimension or order of the above matrix is 3 by 4. Okay, 3 by 4 pala. Nauna yung kung ilan tong rows, tapos ilan yung column next. Meaning that it has 3 rows and 4 columns. So, row ang nauna. Numbers that appear in the rows and columns of a matrix are called elements of the matrix. So, bawat isa niyan, tawag is elements. In the above matrix, the element in the first column of the first row is 21. Ito yun. First column of the first row. The element in the second column, ito, of the first row is 62, and so on. Yan ang matrix. Okay? Matrix element. So, consider the matrix below, ito, in which the matrix elements are represented entirely by symbols. A11, rows and column. A11, so first row, yan, and second column. And so on. So, by convention, first subscript refers to the row number, and the second subscript to the column number. Thus, the first element in the first row is represented by A11. The second element in the first row is represented by A12, and so on until we reach the fourth element in the second row, which is, ito yung second row, A24. 2, second row, 4 is the fourth column. So matrices, there are several ways to represent a matrix symbolically. So the simplest is to use a bold-faced letter, yung bold, just A, B, or C. Okay, thus A might represent a 2 by 4 matrix as illustrated below A. So ito ang matrix niya. 11, 62, 33, 93, 44, 95, 66, 13. Yan. So parang vectors. Another approach for representing matrix A is equal to, ito yung ibang symbol naman A, I, J. So meron siyang bracket dito. Where I is 1, 2, and J is 1, 2, 3. So this is the number of rows, 1, 2. J is the column, 1, 2, 3, 4. Yeah. Okay, this notation indicates that A is a matrix with 2 rows and 4 symbols. So, lalagay ka pa ng rows and columns. So, dito, wala kang ilalagay. So, the actual elements of the array are not displayed. So, they are represented by the symbol AIJ. Okay? Itong sa loob na yan, ito yan, AIJ yan, I and J. Okay. Matrix equality. Okay. Two matrices are equal if all three of the following conditions are met. Each matrix has the same number of rows. Yan. Pag 2 rows, so pareha siya. All three are all three. Each matrix has the same number of columns. Yan. Corresponding elements with each matrix are equal. So, equal siya. So, consider the three matrices shown below. A is equal to 1, 1, 1, X, Y, 4, 4, 4. Matrix B is 1, 1, 1, 2, 2, 2, 3, 3, 3, 4, 4, 4. And C is equal to L, M, N, O, P, Q. Matrix niyan. If A is equal to B, so X is equal to 2, 2, 2, and Y is 3, 3, 3. Since corresponding elements of equal matrices are also equal. And we know that matrix C is not equal to A or B because C has more columns and than A or B kasi tatlo na ang columns ito. So, hindi talaga siya mag-equal. Next, example number 34. The notations below describe two matrices A and B. So A, matrix A, AIJ, where I is 1, 2, 3, 4, and J is 1, 2. Sabihin, and B is equal to 1, 1, 1, 2, 2, 2, 3, 3, 3, 4, 4, 4, and so on. Based of the following statement above, A and B are true. Okay. 1, matrix A has 5 elements. 2, dimensions of matrix B is 4 by 2. A and B, A and B. Ano yun ang totoo sa A and B? So 3, and matrix B, element B2, 1 is equal to 2, 2, 2. Okay. A, 1 only. B, 2 only. C, 3 only. B, D, none of the above. Okay. Solution, so answer is letter D. Ano? Matrix A has 3 rows. Diba? Yung I, 1, 2, 3. And 2 columns. That is 3 rows, each with 2 elements. This add up to 6 elements altogether, not 5. Okay? Tama. So, mali yung letter A. So, the dimension of B is matrix 2 by 4, not 4 by 2. That is, matrix B has 2 rows and 4 columns. So, not 4 by 2 columns. So, number 2, Sloma number 2 is wrong. And finally, B21 refers to the first element and the second row of the matrix B, which is equal to 5, 5, 5, not 2, 2, 2. Okay. So, letter C ito, number 3, is not correct. Sabi dito, following statement about A and B. So, kahit isa lang magkamali ka, dito to dito, so, mali na. Okay? So, kaya ang sagot is none of the above. Type of matrices. Transpose matrix. The transpose of a matrix is another matrix that is obtained by using rows from the first matrix as column and the second matrix. So, na doble lang yung pagka-type. Okay? By using. For example, it is easy to use that the transpose of A is A prime. Rows 1 of matrix A becomes column 1 of A prime. So, rows 2 of A becomes column 2 of A prime. And rows 3 of A becomes column 3 of A prime. So, ito yung A is equals 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. So, ang transpose niya is magiging, kung ito 3 rows, ito magiging 2 rows na lang. So, ito, ililipat mo doon. 1, 1, 3, 3, 5, 5, 2, 2, 4, 4, 6, 6. So, yan. Note that the order of matrix is reversed after it has been transposed. So, A is 3 by 2, but the matrix A prime is 2 by 3. Okay. Huwag natin i-correct yung by using. Tagal pa. Types of matrices. Merong vectors. So, meron vectors din dito. Vectors are a type of matrix having one column or one row. So, yan, tawag. Vector comes in 2 flavors. Column vectors and row vectors. For example, matrix A is a column vector and A prime is a row vector. So, this is the column vector and row vector. Ang application yan, so, balikan nyo yung vectors na. Square matrix. So, yan lang yan. Square, equal. A square matrix is an n by n matrix that is a matrix with same number of rows or column. Symmetric matrix, if the transpose of a matrix is equal to itself, that matrix is said to be symmetric. Two examples of a symmetric matrix appear below. A is equal to A prime is 1, 2, 3, 4. Yan, di ba? Okay, Chino. B prime is 5, 6, 7, 5, 3, 2, 1. Andyan yung mga numero yan. So, yan. Note that each of these matrices satisfies the defining requirement of symmetric matrix. A is equal to A prime and B is B prime. Next, diagonal matrix. A diagonal matrix is a special kind of symmetric matrix. It is a symmetric matrix with zeros in the off diagonal elements. Yung wala sa diagonal, zero siya. Two diagonal matrices are shown below. So A is equal to 1, 0, 3, 3. B is 5, 0, 0, 0, 3, 0, 0, 0, 1. This is symmetric matrix and diagonal matrix. Note that the diagonal matrix refers to the element that runs from upper left corner to the lower right corner. Ganyan ang ano niya. Hindi yung papataas pag ano na, ganyan ang diagonal matrix. Scalar matrix. A scalar matrix is a special kind of diagonal matrix. It is a diagonal matrix with equal valued element along diagonal. So yan naman. Two example of the scalar matrix appear below. So yan, tingnan niyo lang. Tingnan niyo na lang yung example. So example number 5. Consider the matrices shown below. So letter A, capital A, B, and C. So A is 1, 2. B, A is 3, 5, 4, 6. B is 3, 4, 5, 6. Tignan nyo na lang C is equal to negative 1, 0, and 6. Which of the following statements are true? A is a raw matrix. Oops. 2 is A is equal to B prime. 3 is asymmetric matrix. So A is 1 and 2. B is 1 and 3. C is 2 and 3. Then the correct answer is C, as explained below. Matrix is a column matrix, not a row matrix. So A choice is not the answer. The transpose of a matrix is created by interchanging corresponding rows and columns. So when this is done, the matrix B, to matrix B, we see that A is equal to B prime. So sabihin 2 is correct. So 2. So since A is wrong, B is wrong kasi 1 nga, hindi tama. So C ang naiwan mong choice, no? So transpose of C, next, i-check natin. The transpose of C is equal to C prime. That is C is equal to C prime. Therefore, C is a symmetric matrix. So 3. This is correct. So 2 and 3 is correct. The correct answer is letter C. Di ba? Dapat alam niyo yun. Kasi baka kung merong ibigay na ganito sa board, so may ideya na kayo. So matrix addition and matrix subtraction. How to add and subtract matrices. Two matrices may be added or subtracted only if they have the same dimension. That is, they must have the same number of rows and columns. Addition or subtraction is accomplished by adding or subtracting corresponding element. For example, consider matrix A and matrix B. So A, this is the value. B, this is the value. Both matrices have the same number of rows and columns, 2 rows and 3 columns. So they can be added and subtracted. So by addition, A plus B is equal to 1 plus 5, magiging 6. 2 plus 6 is 8. 3 plus 7 is 10. So ganun din sa baba. So minus is ganun din. 1 minus 5, 2 minus 6, 7. So yung taas magiging negative 4, negative 4, negative 4. This is now 4, 4, 4. So yan. And finally, note that the order in which matrices are added is not important. Thus, A plus B is equal to B plus A. Okay. Sample number 36. Consider the matrices shown below, A, B, C, and D. A is equal to matrix 1, 2, B, 3, 5, 4, 6. Tingnan na lang. C, 4, 5, 6, 6. D, negative 1, 0, negative 2, 0. Which of the following statement are true? So, 1 is equal to A plus B C, or C. 2 is equal B plus C is equal to 2. 3 is equal to B minus C is equal to D. Okay? Yun yung ano. Tingnan nyo na lang yung matrix. Hindi ko matandang paano yung basahin. Basta kasi wala pa search kung paano basahin yung matrix. So, A, 1 only. B, 1 only. Oops. 2 only yata yan. 2 only. C is 3 only. D is 1 and 3. Okay? So, solution, the correct answer is C as shown below. So, doon tayo, A plus B is equal to C. So, A plus B cannot be added. Kaya, mali. 2, B plus C is equal to D. So, try mo. 3 plus 4 is 7. So, hindi, yung D mo is negative 1. So, mali pa rin. Number 3 is B minus C. So, 3 minus 4 is negative 1. So, 4 minus 6. So, 5 minus 5 is 0. So, tama yung, yung letter C. Okay? Matrix multiplications. Yan. How to multiply a matrix by a number. So when you multiply a matrix by a number, you multiply every element in the matrix by the same number. This operation produces a new matrix which is called scalar multiple. For example, if x is 5 and the matrix is A, then A is 100, 200, 300, 400. So XA is equal to 5A is equal to 5 times 100, 200, 300. I-multiply mo lahat. So lalabas 500, 1,000, 1,500, 2,000, which is now equal to B. In this example, every element of A is multiplied by 5 to produce the scalar multiple B. Now, how to multiply a matrix by a matrix. So suppose that A is an I by J matrix and B is by J by K matrix, then the matrix product AB results in a matrix C, which has I rows and K columns. So nawala yung J. And each element and C can be computed according to the following formula. So say IK is equal to the summation of J, AIJ, BJK, so J, where CIK is the element and rows I and K column form from matrix C. So yan ang yung position niya sa matrix C sa pagtot. So AIJ is the element and row J and column J from matrix A. And BJK is the element and row J and K column and J from matrix B. Okay? Summation of J, summation sign, which indicate that AIJ, BJK term should be summed over. So yan ang magiging doon sa C niya. Example naman tayo. So let's walk to an example to show how the above formula works. Suppose we want to compute AB, given the matrices A as 0, 1, 2, 3, 4, 5. Ganyan daw ang pagbasa. B, matrix B as 6, 7, 8, 9, 10, 11, which is 3 by 2 matrix. And let AB is equal to C. So because A has 2 rows, we know that C will have 2 rows. Okay? And because B has 2 columns, we know that C will have 2 columns. Yan. Okay. Ba? Yan na instruction kanina. Ito. So to compute the value of every element in 2 by 2 matrix, we use the formula summation of IK is equal to the summation of IJ, BK as shown below. So C11, yung sa first row, first column, first row, first column ng C is the summation of A1, J, B, J1. Okay? Kasi INK tayo. This is lahat ng A1, B1. So sa A is 0. Sana yun? 0. Then, nag-umpisa tayo sa 1. So A11, then B11. So 6. So 0 times 6. So 1 naman, A12, then 21. Okay? A12, E12, 1. Ito na. Then B21, 2, 2, 1. So 8. Yan. Tandaan nyo, formula lang yun. So plus A13 and B31. A13, 1, number 3. Ito. 3 column. Third column. Then B, third row and first column. This is 10. Okay. So kaya 2 times 10. So 28. Yan. So ito na yung andito sa first row, first column mo. Kaya 1, 1. Same din sa C12. Saka C21, C22. Hanapin mo yan. Ito na ang result mo. Okay? So kailangan yung kung ipapamilya sa matrix multiplication, kailangan ito bilang kodigo. Yan. Identity matrix. The identity matrix is an n by n diagonal matrix with ones in the diagonal and zeros everywhere else. So the identity matrix is denoted by capital I or IN. So two identity matrices appear below. So I2 for 2 by 2 is 1, 0, 0, 1. So I3 sa 3 by 3 is 1, 0, 0, 0, 1, 0, 0, 0, 1. So the identity matrix has a unique talent. Any matrix that can be pre-multiplied or post-multiplied by I remains the same. Ito yung pre-multiplied before. Then post-multiplied is after. They are the same. So example number 37. Mahaba itong matrix. Consider the matrices shown A, B, and C. So A is A, B, C, D. B is equal to E, F, G, H. C is equal to W, X, Y, Z. Assume A, B is equal to C. Which of the following statements are true? So yan. WA is W is equal to AE plus BH. X is equal to AF plus BS. Y, letter C, GCG plus D, all of the above. So the correct answer is B. Okay, bakit? To compute the value of any element in matrix C, we use the formula C I K is equal to summation of J, AI, J, B, J, K. Isa-isahin mo yon. Okay? Sa unang ito. Makuha mo to. C11. And matrix C, X is the element in row 1 and column 2. Okay. Which is represented in the formula by C12. Therefore, to find X, we use the formula to calculate C12 as shown in below. So X equal to C12 is equal to summation of A1J BJ2 is equal to A11 B12 plus A12 B22 is, this is A11 A, B12 F. Okay. Then A12 B and ito, H. Ayan. So, ito nyo yung iba, yung W, saka yung Y. Ito yung W is C11, saka this is the C21. I-try mo, incorrect siya. Okay? So, ito lang ang tumama. That is letter B. Vectors multiplication. Vector inner product. Assume that A and B are vectors, each with the same number of elements. Then, the inner product of A and B is S. A prime B is equal to B prime A is equal to S. Where A and B are column vectors, each has an element. A prime is the transpose of A, which makes A prime a row vector. Vectors, pero wala pa natin na yung isang linya lang. Itong column vectors, vertical. Yung row vector is horizontal. Discuss natin, di ba, kanina? So B prime is the transpose of that. So S is a scalar quantity. Scalar, that is, S is a real number, not a matrix. So, yan. Vector outer product. Assume that A and B are vectors, then the outer product of A and B is C. So A B prime is equal to C. A is a column vector having M elements. B is a column vector having N elements. B prime is transpose of B, which makes B prime a row vector. So NC is a rectangular M by N matrix. Yeah. Diba? Bandi yan parehas na kasi ito AB prime to B prime A. Check nyo na lang. Vector outer product. Oops. So, tanggalin natin to kasi nadoble lang. Wait. Okay, example number 38. Consider the matrices shown below A, B, and C. A is 0, 1, B is 2, 3, C is 4, 5, 6. Ito yung mga vectors. Using A, B, C, answer the question below. Find A prime B, the inner product of A and B. And B, find B, C prime, the outer product of B and C. Okay, true or false? B, C prime is equal to C, B prime. Solution A, the term A prime B is the inner product which is equal to 3. The solution appears below. Alright, di ba lalabas? Okay, wait baka di na isagat. Okay, so inayos ko lang. Nawala kasi yung solution. So the solution appears below. A prime B is equal to 0, 1. A prime is the transpose of A, which is 0, 1 vector, column vector. Now becomes row vector 0, 1. Times B is 2, 3. So magiging 0 times 2 plus 1 times 3. Diba? Is equal to 3. So the answer for letter A is 3. The term BC prime is an outer product which results in a 2 by 3 matrix. C primes is, ito na, row matrix na yan, 4, 5, 6. Yung B is 2, 3. So magiging 2 times 4 plus 2 times 5 plus 2 times 6. Yan. Hindi plus, hindi plus yan. Okay. Location as 3, 4. Tapos 3 times, oops, sorry. This is 5. Wait. Okay, sorry. This is 5. So then 3 times 6. Lalabas, ito is 8. 2 times 5, 10. 2 times 6, 12. So ba, 12, 15, 18. This is now the product of vector matrix D. Okay. This is now the answer. A matrix. So the statement, di ba yung BC prime, ang labas niya is matrix. Sabi dito sa outer product. Saan? Ito. C is a rectangular matrix M by N. Okay. So let us see the statement BC prime and CB prime is false. Bakit? Note that B is a 2 by 3. BC prime is a 2 by 3 matrix. B times yung ano nito is 4, 5, 6 horizontal, C prime. So magiging 2 by 3 matrix siya, di ba? Nauna kasi yung row 2 by 3 matrix. So, and CB prime is a 3 by 2 matrix. So, C ito. Tapos, ito magiging B prime 2, 3 horizontal. So, magiging 3 by 2 matrix. Because BC prime and CB prime have different dimension, they cannot be equal. Yan. Okay. So, pause muna tayo. Okay. Matrix rank. The rank of a matrix. You can think of an R by C matrix as a set of R row, yung R row yan, vectors, each having C elements. Vectors, ibig sabihin, isang row lang. Okay? Or you can think of it as a set of C column vectors. Ang vectors, iba, isang column lang yan. The set niyan. Each having R elements. The rank of a matrix is defined as A, the maximum number of linearly independent column vectors in the matrix, or B, the maximum number of linearly independent row vectors in the matrix. So equal yan na A and B. Maximum number of linearly independent. So walang multiple. Yung multiple niya is isa lang yan. Isa lang ang bilang nun. May example naman tayo. For an R by C column, if R is less than C, then the maximum rank of the matrix is R. If R is greater than C, then the maximum rank of the matrix is C. This is the maximum, not the actual rank of the matrix. The rank of a matrix would be 0 only if the matrix had no element. If a matrix had even one element, its minimum rank would be 1. So next is the full rank matrices. So full rank ito ang dito sa explanation na to is malalaman mo yung ang ibig sabihin ng full rank. When all of the vectors in a matrix are linearly independent, the matrix is said to be full rank. Consider the matrices A and B below. A as 1, 2, 3, 2, 4, 6. B 1, 0, 2, 2, 1, 0, 3, 2, 1. Notice that row 2 of matrix A, ito, is a scalar multiple of row 1. Ito yung row 2. Ito yung row 1. So, multiply mo ng 2 by 2. So, twice row 1 is magiging 2, 4. So, ito naman, multiple din to ng, ng 1. 3 and times 3, 6. Okay. So, therefore, row 1 and 2 sa 3 is linearly dependent. Matrix A has only one linearly independent row, so its rank is 1. Hence, matrix A is not full rank. Hindi niya naubos yung tatlong row. Okay, now look at matrix B. All of its row are linearly independent, so the rank of matrix B is 3. Matrix B is full rank. Yan ang ibig sabihin niya. Next, matrix determinants. Suppose A is a matrix A is a 2 by 2 matrix with elements Aij is shown as shown below. A is equal to A11, A12, A21, A22. So we compute the determinants of A according to the following. So tatawag dito is determinant, hindi yung value ng matrix sa lagit. Ang tawag dito is determinant is A11 times A12 minus A12 times A21. Okay? Ito muna, pababa, then pababa to the right, then pababa to the left. Yan, ang ano niya, minus. Next, how to compute the determinants of an n by n matrix. So, iba yung ano na, other than 2. The formula for computing the determinants of a 2 by 2 matrix shown above, kanina, is actually a special case of general algorithm for computing the determinants of any square matrix. So determinants A is equal to the summation of plus or minus A1Q, A2R, A3S up to A and Z. So this algorithm requires some explanation. So here are the key points. The determinant is the sum of the product terms made up of elements from the matrix. So each product term consists of n elements from the matrix. Each product term includes one element from each row and one element from each column. Number of product terms is equal to n factorial, which represent. By convention, the elements of each product term are arranged in ascending order from the left hand or row designating subscript. Ito ka mag-ano, ascending, 1, 2, 1, 2, 3, yan po na yan. So, to find the sign of each product term, we count the number of inversion needed to put the right hand or column designating subscript in numerical order. If the number of inversion is even, the sign is positive. Okay, 1, 2, so positive yon. If add, the sign is negative. So 1, 1 is so may example naman to. Suppose A is 3 by 3 matrix with elements Aij as shown below. So A is equal to A11, A12, A13, A21, A22, A23, A31, A32, A33. So ito yung 2 by 2 saka 3 by 3 yung pinaka-common sa atin, di ba? So to begin, list its product term. In constructing this list, we will arrange element of the product term in ascending order of their row designating subscript. Our list of product term appears below. So yan. The formula, ito. Then, ito na yung list. Plus or minus A11, A22, 33. Plus or minus A12, so dito 3. 1, 2, 2, 3. Ano sunod niya dito sa kabila? 3, 1. Plus or minus A3, 1, 3. 1, 3 tapos 2, 1, 2. And so, tapos dito naman. Then, so dito naman, 1, 3, 2, 2. Yan. Tapos dito, yan. Ayan ang order mo. Lahat na nalagay mo na, di ba? Note that we have 3 factorial or 6 product term. 1, 2, 3, 4, 5, 6. Each consisting of one element from each row and one element from each column. The task remaining is to find design for each product term. To do this, we count the number of inversions needed to put elements in ascending order of their column, designating subscript. Column yung isang pangalawa. To demonstrate, ito yan, how to count inversion, let's look at the two of the product terms. Consider the second product term in the list, A122331. To put all of the column designating subscript in ascending order, we need to move 831 from the end of the term to the front of the term. So which results 831, 1, 2, 2, 3. This movement count as 2 inversion. Since we move 831 2 position to the left. So since 2 is an even number, the sign of that product term should be positive. So positive na yan. Count the last product term in the list A11, 2, 3, 3, 2. To put all of the column designating subscript in ascending order, we need to interchange the second and third. Yung column na ito. So maging 1, 2, 3. Column designating subscript 1, 2, 3. Ito naman magiging 1. So pagbalitan mo ito para maging 2, 3. Yan. So this count as one inversion. So we move 832 one position to the left. So since 1 is an odd number, the sign of the product should be negative. So this is minus. Ganun na rin dito sa iba. So this is no inversion tong una. 1, 2, 3. So positive. Tingnan natin baka madoble tayo. If we repeat this process for each of the other product term, we get the following formula for determinants of a 3x3 matrix. Yan. Okay. Kita nyo dito lahat ito nag-minus. So, ibig sabihin, in a simple way, multiply mo ito mag-add, minus, yung total naman nitong sa, from upper right to lower left. Yan. Yun ang procedure dito sa 3x3. Okay? Pwede ako naka-record. Ayan. Example number 39. What is the determinant of matrix A? A is 5, 1, 2, 6. So, solution, correct answer is D. Based on the matrix determinant algorithm below, A is the formula. Then, because A is 2 by 2 matrix, we know that the determinant algorithm has 2 prime, a factorial, or 2 product terms. And each product terms include one element from each row and one element from each column. We list the product terms below with the elements of each product arranged in ascending order of the left hand or the same row designating subscript. So, yan. Okay, A is equal to plus or minus A11, A22, plus or minus A12, A21. So, ito automatic itong 1, 2. So, this is 0 inversion. So, positive. Karugtong. Itong explanation to, pero kung gano'n, solve na. Hindi na kailangan explanation yan, di ba? To determine whether each product term is preceded by a plus or minus sign, we count the inversion needed to put all of the column designating subscript in ascending order. The column designating subscript for the first term, A11, A22, are already in ascending order. So the first term needs 0 inversion. Since 0 is an even number, the sign of the first term is positive. For the second term, A1221, we must move the second element A21 one position to the left. That is, we need one inversion to put the column designating subscript in ascending order. Since 1 is an odd number, the sign of the second term is negative. So the formula for the determinant of 2 by 2 matrix is thus A is positive A11, A12 minus A12, A21. So that is 5 times 6 minus 1 times 2 is 28. So matrix inverse, matrix inversion. So iba yung kanang inversion na yung pagpalit-palit ng ano. Ito naman matrix inverse. Suppose A is an n by n matrix, is a square matrix. The inverse of A is another n by n matrix. Divided by A negative 1. That satisfies the following conditions. A and times A negative 1 is equal to A negative 1 times A is equal to IN, where IN is the identity matrix. Below, with an example, we illustrate the relationship between a matrix. So, A, 2, 3, 4, 2, 1, 3, 4. So, the inverse niya is 1 over is 0.8, negative 0.2, negative 0.6, 0.4. Is equal, also equal to, pag pinalit mo siya, so this equal to 1, 0, 0, 1. Not every matrix has an inverse, but a matrix does have an inverse. It is unique. Yan. Hindi ito 1 over 2 is 0.8. Hindi yan. So does the inverse exist? There are two ways to determine whether the inverse of a square matrix exists. Determine its rank. The rank of a matrix is a unique number associated with the square matrix. If the rank of an n by n matrix is less than n, the matrix does not have an inverse. Ayan. Compute is determinant. The determinant is another unique number associated with a square matrix. When the determinant for a square matrix is equal to 0, the inverse for that matrix does not exist. Siyempre, 0. 1 over 0. Infinity. Ano? So, example number 40. Consider the matrix A shown below. A, 2, 4, 1, 2. Which of the following statements are true? A, the rank of matrix is A is 1. B, the determinant of matrix A is 0. C, the matrix A is singular. D, all of the above. Okay, so the correct answer is D, all of the above. Why? The rank of a matrix is defined as the maximum number of linearly independent row vector in the matrix. Rows 1 and 2 of matrix A are not independent. So since row 1 is equal to 2 times row 2, therefore A has only one independent row, so its rank is 1. So tama yung letter A. Okay, find the determinants of A, which is denoted by a symbol. So this is not equal to, this is equal to 0. Okay, matrix is not a full rank, and its determinant is equal to 0. Therefore, matrix A does not have an inverse, which means that matrix A is singular, nag-iisa. Okay, so lahat yan tama yung ABC. So the answer is all of the above. Okay, how to find the inverse of a matrix? So, special cases. How to find the inverse of a diagonal matrix? A diagonal matrix is a special kind of symmetric matrix. It is a symmetric matrix with zeros and the off-diagonal elements. Yung wala sa diagonal. So, two diagonal matrices are shown below. A, 1, 0, 0, 3. Matrix B, 5, 0, 0, 0, 3, 0, 0, 0, 1. Note that the diagonal of a matrix refers to the element that run from upper left corner to the lower right corner. Pag ganun. So the inverse of a diagonal matrix is obtained by replacing its element in the diagonal with its reciprocal. Ayan. As illustrated below for matrix C. So yan, ito 1 over 2, 0, 0, 1 over 4. Yan lang. Okay? It is easy to confirm that C negative 1 is the inverse of C, since C negative 1 is equal to C negative 1 C, where I is equal to I. I is the identity matrix. This approach will work for any diagonal matrix as long as none of the diagonal element is equal to 0. Yeah. Walang 0 dito. If any of the diagonal elements are equal to 0, the matrix will be less than full rank and the matrix will not have an inverse. Pag wala. Pag may 0 kayo sa none of the diagonal element is equal to 0. Yeah. None of the diagonal elements. So how to find the inverse of a 2 by 2 matrix? Suppose A is a non-singular matrix 2 by 2 matrix. So my inverse, the inverse of A can be computed from A as shown below. A11, A12, A21, A22. So ang inverse niya is A22 over A, determinants of A. A12 divided by determinants of A. So yan ang ano niya. Then negative A21 over A and A11 over A. So yan ito, pumunta dito. Ito, sumakyat. Ito, dyan. Ito, as is. So ito lang nagkabaliktad. Where the determinant of A is A11, A22 minus A12, A21. To illustrate how this works, let's find the inverse of matrix B which appears below. So B is 2, 1, 4, 4. First, let's compute the determinants of B as B11, B22 minus B12, B21 is 2 times 4 minus 1 times 4 is 4. Then we can find the inverse as shown as B negative 1 is B22 over determinants of B minus B12 over B. Negative B21 over B. B11 over B is 4 over 4 minus 1/4. Negative 4/4, 2/4 or equals to 1. Negative 1/4, negative 1, 1/2. Warning, if the determinants of a matrix is equal to 0, then the matrix does not have an inverse. Yan yung purpose dyan. For example, number 41. Find the inverse of matrix A shown below. So A is 2, 0, 0, 8. Solution. The inverse of a diagonal matrix is obtained by replacing each element in the diagonal with its reciprocal as shown below. So that is A negative 1 is 1/2, 0, 0, 1, 8. Example number 42. Find the inverse of matrix A as shown below. A is 3, 1, 9, 4. So solution. First, let's compute the determinants of matrix A. A is A11, A12 minus A12, A21 is 3 times 4 minus 1 times 9 is 3. Then we can find the inverse as shown below. A negative 1 is A22 over A minus A12 over A minus 21, A21 over A, A11 over A, positive. So this becomes 4 over 3. Ito yung 2, 2. 4 over 3 minus 1 over 3, negative 9 over 3, 3 over 3. So equals to 4 over 3 minus 1 over 3, negative 3 and 1. So this is now the inverse. Next, eigenvalues and eigenvectors of a matrix. So an eigenvector of a square matrix is a non-zero vector that after being multiplied by the matrix remains parallel to the original vector. Yan. Isang ano lang yan, isang column or isang row. Okay? Vector kasi ang tawag. So eigenvalue is the value that the eigenvector is scaled by when multiplied by the matrix. Okay? May mga example tayo. The eigenspace is the set of all eigenvectors that have the same eigenvalue. And it also includes the zero vector. Mathematical expression. A times B is equal to lambda times B. A is the square matrix. B is the non-zero eigenvector of A. Yan. So lambda is the eigenvector, eigenvalue, value, hindi value sa vector, A of A that corresponds to B. It is the scalar that when multiplied by the eigenvector produces A dot AB. Diba? Scalar siya. So, naging factor lang siya doon. So these properties exist for every size square matrix. Sample 3 by 3. So, example, A1, B1, C1, A2, B2, C2, A3, B3, C3. This is 3 by 3. Ito yung vector XYZ is equal to lambda times XYZ. Check natin. So, computing the eigenvectors, eigenvalue and eigenvector. So, A minus lambda I, B is equal to 0. This is the characteristic equation. Equal to kanina kasi yung I is 1. A is the square matrix, B is the eigenvector, lambda is the eigenvalue just as in the original equation. I is the Ni by N identity matrix. A minus lambda I cannot be invertible. The equation is solved by 4B to find eigenvectors. Depending equal mo sa 0 yan. The eigenvalues are found by finding the roots of the equation below. Determinants of A minus lambda I. Solve for the lambda. So finding the eigenvalues. A, 6, 16, negative 1, negative 4. Example number 43. So A minus lambda I is equal to 6, 16, negative 1, negative 4 minus lambda times 1, 0, 0, 1. So this becomes 6 minus lambda kasi ito multiply mo dyan sa loob, di ba? Then 16 minus 0, negative 1 minus 0, negative 4 minus lambda. So equal to 0. So ito na yan. So kunin mo yung determinants niya. Di ba? Magiging, ang eigenvalue mo is 4 and 2, negative 2. So finding eigenvectors ulit. When our lambda is equal to 4, so A times xy is equal to 4 times xy. So this is 6, 16, negative 1, negative 4 times x over y is equal to 4 times xy. So solving 6x plus 16y is equal to 4. 2x plus 16y is equal to 0. So negative x minus 4y is equal to 4y. X plus 8y is equal to 0. Therefore, y is equal to 1. X negative 8. So eigenvector now is negative 8 on 1. Yan yung vector. When lambda is negative 2, so a, xy, 4 times xy. So magiging 6, 16, negative 1, negative 4 times xy is equal to negative 2 times x over y. Solving 6x plus 16y is equal to negative 2x. 8x plus 16y is 0. So negative x minus 4y is negative 2y. Then x plus 2y is equal to 0. Ito yan. Yan, ano ba? So y is 1 and x negative. So eigenvector mo is negative 2 and 1. Yun. So, ito na nag-end yung lecture 3. So, marami pa yung sa topic sa matrix. So, kayo na lang mag-expand. Review lang naman to. Thank you very much.